So welcome everybody. This is the Charlotte Python Meetup's first virtual uh, webinar. I hope you guys enjoy. And if you have any questions, there's uh, a Q&A feature where you can post your questions up. So for today, we are going to talk about logs. How I learned to stop worrying and love the logs. A Kubrick reference for you guys out there. And Eric Moss is going to give the presentation, IT consultant for 20 years, and is currently a site reliability engineer and an Elasticsearch consultant. But before we start, I want to thank Faith from Elasticsearch for allowing us to use their Zoom account. So Faith, if you want to step in for a second and say something.
Yeah,
Yeah.
absolutely. Yeah, thanks, Jimmy. We're really excited to be partnering with the Charlotte Python user group on this event. And so folks, if you aren't familiar with Zoom webinar, as attendees, you guys don't have video or sound, so you don't need to worry about muting yourself or anything like that. There's also a Q&A feature. So if you have a question for Eric during the presentation, if you could throw it in that Q&A little bubbles at the bottom of the screen here, that would be helpful. Or you could put it in the chat. We'll be monitoring that as well. One thing to be aware of with the chat is when you send messages, you do need to specify who you're intending to send the message to. I'll send a link in the chat to Elastic's virtual user group. We have weekly meetups that we're putting on right now. So we'd love to have you join that user group as well and get some more information about Elastic that way. And I'll send a link to our community Slack workspace as well. So if you have any questions and want to follow up afterwards, we'll be happy to do it in either of those spaces. So thanks again.
All right, thanks.
Thank you, Faith.
I'm sorry. So just in case you guys are wondering, we are recording this, and we should be able to post it on our Meetup site on Monday. So with that said, I'll pass it on to Eric. Eric, do you want to start?
Sure, man. I appreciate it, Jimmy. Thank you, Faith, for lighting this up and coordinating it all. I guess I'll start from the top here. So my name is Eric Moss. I am, like Jimmy said, a 20-year IT consultant. I've started in the on-prem world years ago. Have maintained a foot in dev and infrastructure. Worked on a bunch of different projects, a lot of data science projects, a lot of infrastructure projects. So visibility's been a big part of that career. From Nagios to pulling logs over VPN via FTP back in the day, and things have become more sophisticated as of recently, and I'm going to show you how to leverage the tools of today. So here we go, and hopefully I can make a 30-minute presentation on logs interesting. I'm going to try here. So so there's the Dr. Strangelove. We'll move right into it. So so the goals today is to one, create an awareness around the application logging and the implications of code time decisions, and then sort of a tongue-in-cheek thing here, and to convince you that logs are not only important, but as a species, our social evolutionary trajectory hangs in the balance. It's that important. And two, to enable developers to quickly scaffold an elk logging ecosystem locally. The hope is that to give context to that sort of operation that gets overlooked most of the time. So just to jump in, what is a log? I went and looked at the etymology of log, and it turns out it's I thought I would get the log, and it turns out that this was actually a tool that you would throw a piece of wood off that had a rope attached to it, and as it unwound from the spool, you would count the knots, and this is how you get nautical speeds. So in knots, and I've got a picture of that on the next slide. But really, what is a log? It's a sequence of journaled entries. just like a commit log, a file system, DB, etc. Basically, you know, a log is data is the point I'm going to beat to death here. So yeah, so let's start at the beginning. Logging history. This is how important it is, truly. It started with the Egyptian priests and scribes in 3400 BC, and then to the Sumerian clerics in cuneiform of Mesopotamia around 3200 BC and on. And then we have, you know, records of Greek priests. And logging is what? It's transactional record, essentially. And when I was doing my research, I came across this guy. If anybody knows Greek or knows how to pronounce things in Greek, I'm going to totally botch this, but Herodotus. This dude was the first guy who actually like did time series analysis, like laid things down chronologically. And so this is the first human that, on record that did that, the father of history. Yeah, from the Silk Road to naval shipping logs, you get it, logs. And here's a picture of one of those little things I was talking about. And it's a chip log, yeah, consists of a wooden board attached to a line, the log line. So, yeah, I didn't know this. The log line has a number of knots at uniform intervals. Isn't that right? So, truly, what in God's holy name are you blathering about? Yeah, basically the origins of data and arguably the origins of our collective consciousness and memory as a society have their origins in logging, essentially, right? Yeah, it infers that not only is, you know, logs are data, but data actually, you know, has its roots in logging. Ergo, the data rules apply, and this is really all this is sort of jokey to get to this point. Yeah, we really should be looking for and applying, yeah, meaningful abstractions, you know, abstraction patterns to, you know, or approaches to this subset of functionality, meaning design patterns, standardization, and structure, and like a real consistent taxonomy and schema. And we should have requirements around these things. I've never seen log requirements. So maybe business analytics, real-time analytics, but not true log requirements. This is all from The Big Lebowski. If you haven't seen this movie, you're missing out. It's fantastic. That had not occurred to us, dude. Well, for what it's worth, yeah, full disclosure, this is all speculation on my part, meant to make this pretty painful or just not really interesting part of what we all do, because I think it's overlooked for the most part. I'm attempting to, yeah, bring some interest to it. So, and this is why we don't like it, right? It's just how do you weed through it? You know, from a debugging standpoint, you know, there is a use for it for the developer, you know, real time, and obviously from an investigation standpoint, but there's no guarantees, right? So I'm providing a couple of log examples here. Here's a clip of CloudWatch showing some JSON logging. In the back there, we have some just regular, actually this is JSON Nginx, and then we have Nginx with Apache format behind it. So let's talk about, and I'm kind of going to blow through this because I have like an actual demo here that I wanted to show. So why do we log? We log to investigate issues, as I said, errors, exceptions, business logic fails, accountability, security, auth, etc. And the thing that I don't think gets thought about that much is, you know, aggregation, performing time diffs, sequence time diffs, and just really just like we have the ability to do some really neat stuff that we couldn't do 10 years ago. So to log or not to log, this is the question. What do we log? We log exceptions, frequency always, level critical, field message. Yeah, and errors. Errors are very important, obviously. Yeah, and I you know, recommendation for microservices, specify separate loggers or some way to differentiate between the two. Or use things like request IDs to, in the handling and cascade that into the logs so that you actually have a way to piece together your microservice, all interactions between microservices. What do we not want to log? We don't want to log tokens, keys, and this is me saying this, but events without context. If you're logging stuff that doesn't have context around it, it's not meaningful, and so you're just really just wasting compute and storage. So logging challenges, as I see it, for application developers and just apps teams in general. We have multiple devs working in concert on a perpetual code base. Requirements are product and feature driven and lack logging requirements. Like I said, I've yet to see with a requirement for a product or feature, I've yet to see like real official logging requirements outside of just some maybe analytic stuff that you're trying to provide for customer's sake. It's not consistent, to say the least. App logging is typically unaudited. Implementation is contextually dependent, app to app, function to function, and as such, team to team and person to person, implementations differ. We don't have requirements around these things usually, and so it's like an extra thing that a dev is supposed to do, but there's really not a definition around what the expectation is. So it's basically just like not get caught. I think is the industry standard for the most part. In typical app log structure, only has a common base abstraction to extend. So what I'm saying here is timestamp, level, logger. In Python, there's more, but industry wide, it's not. There may be a few event, PID, things like this, but for the most part, it's lacking, a real schema. Application architectures are becoming increasingly decentralized and complex, meaning standardization, collection, and aggregation are required to make meaningful sense of application execution, use, performance, resource, and allocation. It's harder to collect all these things and aggregate them, especially if they differ in structure and form. There's tons of tools out here to do this, right? Elasticsearch is one of many. It is a very good one, and it's very accessible. I have experience with several of these, and I find myself going back to Logstash, and I think you'll see why in a bit. Ingestion pipelines, this is something that is really use case dependent. I am doing more and more Apache Kafka pipelining just for, it opens up opportunities for real-time analysis, in-queue transformation, and just, it is the scalable ingest pipeline, let's say that. Elasticsearch also has an ingest pipeline. I use that to augment what's coming off Kafka for its worth. And so for the demo today, we're going to go through, basically I've prepared a package that I've pushed up to GitHub that includes some components that will get you up and running with this environment really quickly. And you can start, basically using these tools to audit your logs that you're logging today. And so this is like a really, really basic. This is what we're doing today. We're going to take some Python code. We're going to output it to a log that I have, like I said, predetermined. So if you download, if you pull this package down and follow the README, it's very easy. You'll output to a location. I have Logstash pre-configured to pick these logs up and process them. In some cases, parse, and then forward that over to Elasticsearch, where it will be viewable via Kibana, and all the instructions are in the Git package, but I'm about to go through it with you. So here's the GitHub repo, ESDemo. Yeah, I just posted just a bit ago, so it's up to date. Dependencies to run this, Docker, and then Docker Compose. You can install Docker for your platform. I've only tested this on Mac, but I feel pretty confident that Docker, yeah, will, if you can get Docker running on your box, which is very easy, it's a next install for most machines, and Docker Compose can be installed via pip or pip3. So what is the repo? The repo contains a Docker Compose file that will launch Elasticsearch, Kibana, Logstash, and APM server pre-configured and ready to go for you. The APM server, we'll have to do an addendum to this because I know I'm going to run out of time. But I included it because it's outstanding and it deserves its own video. And also, yeah, like I said, log configuration files that are driven from environment variables or .env files. And then I've got some Python logging samples to get you started. So whatever level you're at, there's all kinds of stuff out there. I'm going to go through some of the examples. And I thought I took screenshots and kind of brought it in here just to streamline things, but we may click over here in a bit and play with it. So yeah, so this is a basic logging example in Python. I mean, this is like as basic as it gets. This is, you know, as it states, a basic config with a basic format. This is a delimited or space delimited format that's only pulling a couple of values out. I've got more complex, and this is what an output the output of that code specifically looks like. A cool tool I found in the process of preparing for this is colored logs. I don't know if you've seen this, but it's pretty fantastic. I've seen it in other contexts, and I've modified, you know, iTerm to do such things, but this is really just turnkey and easy. You pip install colored logs, you set this up, and basically you can add this to any config and your output becomes color coded. So this makes it very readable nonetheless. Moving on to a more sophisticated example. This is actually, I pulled this from the logging cookbook in the Python org docs for how to implement structured logging. It's a really elegant approach to it. I was just impressed with how elegant it is. It doesn't exact. If you're working in a small code base, you could probably get away with this. But as you start importing other modules and having you know, real structure under your root logger, your details are going to get lost. I believe I haven't tested that, but I feel pretty confident just reading through the code. And this will basically produce. Let me back up real quick. Yeah, so what's going on here? This is, you know, basically setting up, you know, a class that is, I mean, this is so simple. This little encoder, it takes checks and see, you know, checks and to see if it's a set, and then basically returns this encoded JSON. You see this is extended up here, back to this, you know, sort of basic structured message, which they instantiate with an underscore, which looks really strange until you actually see it in context. And really, the benefit of doing this is if you've done much work around the Python you know, logging modules, you know that passing values into it requires you to basically use the extra, and so you have to have like this sort of semi-nested thing. It's not this elegant and clean. But like I said, this is, yeah, it's just pretty. It doesn't have a lot of scalability in my opinion. I may be wrong, but this is the output. And so this is, you know, a JSON encoded, yeah, log message. Notice it lacks a lot of information that's inherently available to us using the Python logger. You could go get that information, and we're going to do that in the next code sample. This code sample, this is something I've been working on. I actually pruned this down a little bit to make it to make it fit on the page, but also to make it more readable and understandable. I went back and forth with the logging module, how best to extend it, and I sort of ended up with this technique, which like I said, I've simplified here for you. Basically, I'm extending the logging formatter and just extending within that class. I'm extending the function format and literally, returning a JSON. Well, you can see I'm going to get a timestamp from UTC now. I'm getting a stack trace via this function, which you can see in the code. I've provided this as an example. It says 04, but this ended up being 03 structured handlers, so forgive that mistake there. But when we drill down further, we have, record.module. Oh, Schema. Let me back up real fast. I'm going to show you do I have a browser somewhere? No? Oh, truly. Sorry. I thought I was looking at VS Code. Talking about Schema, so one thing I did in this code, one of the things I reworked here, lost my way here. One of the things that I reworked was getting this into the Elastic Common Schema format. I think there's probably, I know there's some legacy schema formats out there for logging, but I haven't seen anything this comprehensive. I've been pushing my clients to implement this primarily because it's just a comprehensive schema that I've not found a resource for anywhere else, but also a little side effect, I guess a positive product from that is there's a lot of Elasticsearch functionality that is continuing to roll out that's being designed around the schema. So you're getting a bunch of base analytic sort of looks and features, seams, symmetric stuff, all kinds of stuff really. So if you adhere to this schema, then there are some just like inherent features you get from your logging that you wouldn't otherwise have. So I'm going to flip over and just show you real quick the Elastic Common Schema reference here. So and they've done a really good job. Elasticsearch has done a good job first defining this, and is growing. Like, I remember this, I think it came out 6-8 months ago, something like that. And we're already up to 1.6 actually, the dev version on GitHub. In any case, the GitHub package they provide. For example, I had a client implement this schema, and we were doing a Kafka project, and from the GitHub package, we were able to grab all the YAMLed all the entire schema in a YAML format and just load it as an Avro, as an Avro registry template. So now we have like schema validation at the queue level, which is fantastic. All because we, just like I said, another fruit from using this. It's not perfect. It is comprehensive in so many ways, but it will not fit every use case. It's just the nature of this sort of thing. But it does have a spot for just about everything, all the big spots. So digging into HTTP, for example, you have method place for body content, status codes, versions, etc. I encourage you to look through this. They also have a bunch of tools out there that that you can quickly convert it from the YAML to JSON. They have templates for Elasticsearch to automatically ingest and validate against these data types. So I highly recommend, if you don't know what you're like, if you don't have any sort of predefined schema and you're trying to, I don't know what I should name this, definitely give that a look. And the link is in my README documentation, and I think I can probably find it here really quickly. ECS, GitHub, yeah. Yeah, so I definitely recommend coming out here and perusing this if you're in need of Schema. All right, I'll let it go. All right, so let's get back to it. I think I'm pretty much done with this slide. Oh, no, I'm not. Yeah, so I set up the formatter right here, logging formatter. The next thing I do, and I think this is a pretty cool technique, like basically I smash all this into one file so that you could have a file to reference everything. Also in the file, there's a package that's being referenced that includes, that's the source where this stuff came from. And basically what I've done is I've broken out multiple handlers for different things. Actually, yeah, the goal is like whenever I'm coding and I'm looking at my, my terminal for debug information or log information, really JSON is really sort of hard to read, if it's all compressed. And I mean, this right here, for example, I mean, that's you can do it, but it's not efficient. I love the color-coded tabular format left to right. This is not the best for ingestion, or not the easiest for ingestion, especially if you're doing quick stuff. There is an argument to be made that attaching keys for all these values, like making key value pairs, is actually like creating data and using storage capacity for redundant storage of keys. So in high volume situations, there's an argument to be made for Avro schema and just going not schemaless, but going I guess predicted or predictable schema with a sequence left to right. But for most use cases, and JSON won't bog you down. I think we all know that. You'd have to be producing a ton of logs for that to really have an impact. But I just thought I would throw that caveat out there. Yeah, so what I've done is I've sort of separated these two things so that what is happening here is if you load up this default handler, let me move this out of the way. Yeah, you probably can't see that. All right. So if I the stream handler sets up a console log to the console. The file handler, imagine this, sets up a handler for a file. This is defined right here. This is the path that Logstash is looking at. I'll end up replacing this hard-coded line with a variable. I just had an issue and I pasted it in real quick, and I need to go back and undo that. In any case, be aware of that. I put a comment out beside it. But if you load up your logger just like you do now, import logging, logger equals logging.get logger, open parentheses, underscore name. If you do this and then wrap default handlers around logger, basically what you're going to get is with this file, you're going to get logs that pretty color output to your console, and you're going to get good JSON to your file, and that's going to ingest through Logstash. So here's some examples. I just went ahead and popped them both out in console so you could see them. The way this is set up on the current commit, these things are completely separate. So you would just see the colored lines, and the JSON lines would be in the log file. So one caveat here. So again, in my I've been thinking about ways to improve logging, like to make it easier and that sort of thing. And I did some research and came across this really clever basic idea. By the way, this is what a JSON output of that log looks like when it's formatted. We'll get right back to that. One of the things, like, it occurred to me is, what if you don't have proper logging, or what if you've missed a spot, or what if something goes awry and you just throw in the middle of execution? What if you attempt to divide by 0? without try catch. So yeah, throw a little decorator around it to catch all exceptions, and yeah, route this back to the logger, and you're all good. And you come out with this actual structured output here. You can see it's got a stack trace in it and everything. So that's handy. Okay, so we're done with the slideshow. So yeah, I guess the we could do questions, and then my thought was I would walk you through some of the package here, and then show you how to access and sort of step you through, not completely, but show you the key points to how to get this thing up and running. Jimmy, how am I doing on time, and what do you think?
I think you're good. I think we got 10 more minutes, but I think people will be really interested in seeing maybe something in Kibana to see like how like these logs, when you aggregate them and look at them, like what they look like and how they can be helpful.
Sure. Yeah. So this, all right. No, I agree with you. I'm going to show real quick, because I think hopefully Docker isn't daunting. If it is to you, or if you have any issues, reach out to me, and I'll do what I can to help you. Just real quick, I've included this Docker Compose. You basically change directory out to the out folder, and you run the simple command of Docker Compose up. And once you do that, I'm not going to do that because it'll take some time. Once you do that, you can verify that everything's up by doing a Docker PS. Doesn't look so pretty right there, but it should look like this. And then yeah, you can see that you've got, or I've got Elasticsearch container, Kibana container, Logstash container. Logstash files are up here. There's a config file. This is a pipeline file. You can dig into this if you want to. If you got parsing needs, Logstash is a fantastic tool. It's got a little bit of a learning curve initially, but it's a fantastic, quick, yeah, optimized tool. So I encourage you to look into it. What I'm doing here is taking logs from the path, which this is all mapped to, automatically mapped to this spot based off of environment variables. Temp logs is an internal container path. And then basically to, bring it in as JSON. And I've got some things for URL lib3 here to sort of make use of, basically parse a message line to show you kind of what a traditional parsing would look like. So with that said, logs.app.json. So this is the multi-line JSON log file where everything is outputting. And you can see I've pulled in a lot of extra information here. I've tried to make it as streamlined as I could, but yeah, I pulled in the bulk of what's available via the logging log record object, which yeah is a fantastic module, by the way. But all right, so yeah, to access this, I can come down here and verify. Let's see, I want to go to Kibana. So it's going to be available in 5601. You can get curl to prove it here, but we'll just pull up a web browser real quick and jump in. So yeah, so once you get your deployment going, basically I already left. I left some just scratch logs out here just so that once you saw it come up, you would be able to prove ingestion without having to do anything. And it'll look something like this. And I don't have an active environment here, so I'm generating my own logs. I think yeah, but I'll just show you. So these are basically the logs. These are from the same code base or the same source that I just showed you in the demo. And let's make some use of this. Usually what I do is try to like sculpt out a path or the information that I'm seeking. So depending on your use case, I'll just open up a few things here, or add a couple of these. Yeah, what I'm doing is this is like the raw data. You can search here, you can filter here. So for example, if I was looking for a specific module, I could, you get autocomplete here. I could say event module. And then, you know, I want to see connection pool, which is all related to URL lib. Show me connection pool over the last, whatever, hour. There we are. So it's probably the closest to a real, oh, I think I just changed my time window. Whoops. Let's see this. So, you know, what I was working on, and I'll post a commit for this soon. I'm working on getting request ID so you can get microservice handoffs going locally or within your project. But I also have some visibility around URL lib3, and you could do this. I mean, the slick thing about you know, Python logger is it all stems from one logger. And so implementing this is as simple as, and there's a code example down here. It's as simple as, well, maybe. It is as simple as, it's somewhere here. All right, yeah, so you basically, somewhere in this code, I wrap the default, yeah, here we are. I wrap the logger with a default handler. This is for request ID. Actually, you would do it with whatever module you were interested in. So really, you know, sky's the limit, and it will take that and work it into a JSON format so you can easily use it in this sort of capacity. So yeah, so just out of the box without doing anything. I mean, if you look at the messages on these things, they're really kind of, I mean, that's you know, that's interesting. I have, is this, oh, this, yeah, this is make request. Yeah, yeah, so what can you use here just natively? PID will tell you sequence. Like ultimately, that's your goal, right? To figure out if the sequence of event are you running threaded, and do you have, you know, do you have threads jumping and grabbing, I don't know, memory or resources, or you know, you're trying to chase sequences, and you know, most of the time here. And so how do you do that sort of like out of the box without doing anything? I think it's a combination of module, you know, possibly module or process name. PID is a great one. Thread ID, obviously, and then you know, request ID is the new best practice. You should be generating a request ID with every, you know, inbound connection that you have, and you should throw it in the header and run it outbound with every connection that you make. And likewise, you should throw it in every log so that all of these things, so that the receiving microservice can then take the header and do the same thing, and now you have a sequence of events across applications. So I don't have an example of that. That's a bit hard to simulate. I was actually working on it, but it's you know, I have to build a couple of different you know, apps that were interacting, and I don't have the capacity to do that right now. So in any case, yeah. So what else do I have here? So how do you make use of this? So Kibana has you have this discovery, or this discover tool. I also really like this tool a lot. Whoop, I love this tool, but that'll be next video. If you're interested in seeing the next video, yeah, just message me or Faith or Jimmy, and I'll be posting something in probably a couple of weeks. But the logs here, yeah, this little spot. This is not limited to application logging or application metrics. I mean, you can go and from Logstash point it to your syslog right now and start matching up system level logs with your application logs, etc. And sort of, I mentioned that because let me move this around a little bit so that it's pretty. I'm just going to drop message. I probably should drop these as well, but it's all right. Yeah, so where I'm at, I'm in log settings, and you can basically define your log indices that you want to use this module with. So in this case, I'm using the index name that's all pre-configured is ECS-applog-star, and the log columns down here that I'm defining, you know, these are this is all from the ECS schema and from the data set that I have loaded. And so, you know, I can do things like, let me see HTTP method, or let me see even PID if I really wanted to. I'm going to remove a few of these. That one, request method, and yeah, that looks good. You can move these around. And what this is sort of a real, not sort of, it's a real-time viewer. So as the logs stream in, you can search and filter on them in sort of a, you know, a tell sort of way. So it's kind of like actively looking at a stream of logs. You can expand these logs by bringing that out. If you want more information, you can quickly filter on this stuff. You can say, show me the log origin function where, you know, it's ISS now, it automatically pops up here, and now you can see all of the instances of this occurring. Obviously free text search. Show me the errors, filter out. You can do exclusions, obviously. If you want something to pop, like you can put this into a high resolution mode where you have teeny tiny print, so you have a lot of data on the screen. So if you wanted, I don't know, some number maybe to pop, you can specify that, and or a URL or a module name. It's making a yeah. Well, I'll circle back on that one, I suppose. I think it's because I'm not streaming. Timeline over here. I mean, this is for like real-time streaming. You can adjust the window if you're going back and forth, that sort of thing. Other features, dashboarding, obviously. Under visualize. So the way Kibana works, all dashboards are comprised of visualizations. They have tons of interesting visualization tools, and they're expanding on this all the time. A few of my favorites, time series visual builder is a great one. It's got a little bit of a learning curve, but if you get your head around it, you can do some really fantastic things really quickly. I mean, I've loaded up financial data in here. I've done some like business analytic kind of stuff, just messing around. Heat maps, and also GeoIP. So you can set up ingest IPs or ingestion pipelines to automatically take a IP address and go look up the long and lats and plot that for you, which is fantastic. You know, data tables. This is a good place to start. We'll just start there. It's not real flashy, but this is how you get acclimated to your data, and figure out how to use your data. So basically what I'm looking at is the last 7 days on this particular index, and this is an aggregate count, metric count right here of there's 1,900 records. Okay, so that's not really that interesting. So let's see what we can do. So we're gonna split rows on this. And by the way, this sort of structure, this format, how this is configured, a lot of the different visual tools use the same sort of technique. So once you nail it and figure it out with the data table, you can do really, you know, interesting stuff with other visualizations. So let's just go and do like a date histogram. Let's see what over time this looks like. All right, so it's going to automatically scale this. I think we probably have a limit here of 5 records, or this thing is just windowed in such a way that I just loaded. I rebuilt everything today so that I could make sure it worked when I committed it. And so that's all the data I have in here currently. But you can see over the, this 3 hours, we had 1,300. It's still not that interesting, right? So let's do something. You can stack these.
Eric, I'm sorry to interrupt, but so it's like 6:50 right now. So
Sure.
let's allow some people have some time for some questions. So thanks.
All right. Yeah. No, I'm down with it. If anybody wants to chime in with questions, I can field those and sort of just you can watch me do this while I field questions. So I'll finish my train of thought right here, and then we'll move on to that. So let's go back to the event module. Yeah, there's my 5 minutes. Let's open that up. So basically, what I'm saying is, over time, I want to see how these how this 1,300 breaks out into different events and different event modules. Now you see the same block of time essentially, but now we actually have some delineation here. We'll just change that because I think that one would be more interesting. So now you can kind of see who's doing what, and you can just keep going on this sort of method. They have other techniques like splitting table, where you could do the same sort of idea, but you could break those out into different tables. So if you're going to elaborate on this further, this would be a handy trick. So now I've got everything. Look, I've got the server logger, URL lib, connection pool logger, root log logger, all broken out into the time series. Now I could do more interesting stuff like show me level. It's not really that interesting, but we're getting the terms aggregation for keyword elements. So log level, right? And right now, the way I have this configured, you could do this with any field that's being ingested and parsed. And so, basically you take if you're using Mongo, take your logger that, go get the logger that Mongo uses, and then wrap it with the default handlers, and you're up and running with, turnkey, aggregatable, solution here. So is there any questions? There's no open questions. Well, I solved everything then, I guess.
So maybe here's a question for you. So can you use Elasticsearch like you use Mongo? Can it be just like a document database with quick retrieval?
I was going to do that, but I thought it would make the presentation incestuous and it would be confusing on what was going on. But absolutely, no. Apache Lucene is crazy fast, and Elasticsearch. It's a great search platform. Period. So there's great analyzers like phonetic analyzers, specifically text analyzers. That you can break text out into phonetic sounds based off of all the different phonetic codecs out there, techniques, and then so what that does is help you with misspellings and that sort of thing. You can now take a search criteria, switch it into through the same analyzer, break it down into the same phonetic parts, and you get matches when you start pulling out vowels and basically.
Right. So what if you just want to do just a basic query, like, this field equals this value, right? Like how can you use that in place of Mongo, and are there trade-offs?
Yeah, I mean, they're in different scopes, right? Like Elasticsearch is built for fast. So it's like the iron triangle of database systems. On one vertices, you basically have features on each vertices, big, fast, and accurate. SQL would be the accurate. Basically, one database system can only occupy 2 vertices, right? So SQL is fast and accurate. It doesn't scale, right? On the flip side, Mongo is accurate, transactions, that sort of thing, and big. It's not necessarily fast. In Elasticsearch, and when I say it's not accurate, I mean it's a different scope. It is big and fast is what Elasticsearch does, which is basically proximity searches, probability searches. I'm going to go get all this stuff very quickly and give you approximations. So you don't want to run an ATM transactional system out of it, right? But it would be great for for Wikipedia. In fact, I think Faith, is it the back end of Wikipedia? I think it is.
I'm sorry. Yes, Wikipedia does use Elasticsearch.
So that's a perfect example of a great use case. So you're absolutely right. Like logs is sort of it's not the most interesting application around this. It's got some very cool features, but while you're doing it, you might as well get scope on your logs as well. So. Not to mention ingest pipelines. It's got tools that SQL and Mongo don't have. I mean, it's like a hybrid. It's not quite a queuing system, but it does have, pipelining, transformation, data mining. It's not a replacement for a data warehousing, tool, but in a pinch, you can do some really fantastic things really quickly. With re-ingesting data and, like I said, building out transforms and that sort of thing. You asked about a query. I think it took me a bit. The learning curve was there you go. What is the best approach to migrate SQL server logs to Elasticsearch? Our logs are all right. So what? MS SQL or what is it? Yeah, I'm curious to see. Yeah, this should be pretty easy. So all right. So Microsoft SQL. I'd have to see a code sample. Or let me see It's been a long time since I've looked at MS SQL logs. There was a day and time where I couldn't get my head out of them, but log example. The reason why I'm looking for this is I suspect transaction log. Let's see if we got some. Oh yeah. Yes. So yeah. I would recommend FileBeat for this. FileBeat, I guarantee it has a MS SQL module. Boy, I'm jumping right out there. Actually, FileBeat has a ton of modules, and so they're very easy to configure. Yeah, there we are. Yeah, so here you go. So you could load this up in Docker, or you could just like next, finish, install it. You're going to specify your path, and then this is actually enabling the module. You have to go into this modules folder and rename this from back to MS SQL YAML, configure your paths, and start the service. You'll have to define, your Elasticsearch endpoint, but you can use the package that's out that I posted out there to get up and running. Yeah, this wouldn't take very long for you to do. Yeah, of course. Yeah, of course. And there's other great modules too. So RabbitMQ, Redis, there's CloudWatch modules. You may want to, depending on your goals, you may also want to look at metric beat. So logs are, great for one use, but if you're concerned about, like resource util and that sort of thing, throw metric beat on there while you're doing it, and you'll have, you'll be able to solve a lot of problems. So does that work? Hopefully, yeah, answered. Fantastic.
Okay.
All right. Other questions? Yeah, so let me do this query real quick, if we have time for it. Yeah. So this is another cool thing. Different, this is sort of a different approach than Mongo or traditional database systems. I mean, I can just do a search without even specifying the index. So I mean, I can obviously scope it, which would be more optimized and efficient. So in this case, ECS, this guy right here, or if I had these spanning a bunch of different, I use a wildcard / something like that. It's just real basic like this. This will return. You see, it returned 1900. You see how fast that was? 1900 hits, and there's the actual hits. There is an Elasticsearch a Python package. It's pretty comprehensive, but Elasticsearch is I don't know. I feel like their strategy is to just build out this, like, they've built out this gnarly feature set in an API, and so just about everything's available via API. No, everything's available via API. There are things that Kibana doesn't do yet that Elasticsearch has done for some time. So if you're a command line junkie, I highly recommend digging into this. So let's say I want to do like a specific query. I'll just do one real fast for you. I'm going to do a query. I'm going to do a match. I'm going to match a specific field. We'll just do event module. We'll just use connection pool here. And you can do limits and all this sort of thing. So there's 878 of those, and they're under this hits. So I mean, you can use the Elasticsearch SDK or the SDK, but man, you can also just drop to curl and do it. So that's pretty fantastic, and basically iterate over this, and you're ready to go. The other thing I'll show you that's, I think, kind of cool. So that took 49 milliseconds. Let's see, it took 5 the second time. It automatically caches. So once you do a big query, and you can return 10,000 records at a time pretty quick, pretty easily and quickly. The first time you do it, it will cache, and the second time you do it, it'll be a fraction of the time. So that's pretty fantastic. You can do like more sophisticated. You can do aggregations from here too. So you can like extend this and build out aggregations based off of this. So I've done this query as a first level. Now I could go and build out a second, basically an aggregation. So let's call it, let's see, I got to figure out what we're going to try to do here.
Hey, Eric, I think our time's up at 7:05. So
okay. Yeah, no problem. Yeah, no problem. No, I mean, I encourage everybody to dig into this. I mean, whether you're an infrastructure person or you're a developer or wherever you're at on the spectrum, the API has something for you. By infrastructure person, I mean, like, the clustering on this is really interesting and well built and smart. Likewise, it is just configurable, it's incredible. It's it has that in common with Mongo, I suppose. But no, they're in different worlds. It doesn't work for every use case. Like I said, you don't necessarily want to run a transactional based system off of it. But anything that you need quick, approximate returns. And it could be used in concert with a transactional-based system, right? Like why go to your transactional-based system for all the, for all these quick lookups if you could get it from here and then maybe insert it and use the transactional system for reconciliation or transactions, right? So, all right. Well, I hope everybody found that informative. Feel free to reach out to me if you have any problem getting it working. I'm going to keep developing on it. No problem on the SQL stuff. if you run into problems, just hit me up and I'll do my best to get you going. So, all right. I appreciate everybody's time, and yeah, stay healthy.
All right.